share. Let me know if you can see, please. Can you see?
Yeah.
Yes, we can see.
All right. So I think we have like, what's the time? 11:15. We have 45 minutes to go. So we are going to go very quick. All right. So now issues relating to policy and access, right? So we want to know, how is the data being stored abroad? Like abroad, whose policy do you follow? Like, are you following, assuming I'm in Ghana, and then maybe there are laws in Ghana that is, saying that data has to be protected this way, that way, that way. But then I'm using a cloud service provider in, let's say, I was about to say Ukraine or Russia. I don't know why those examples came up. Let me restructure this. So assuming I have a server in like a country, right? A different country, let's say, okay, let's pick India, right? So we have my servers in India, right? And I'm in Ghana. And let's say Ghanaian laws are saying that you have to protect it this way, that way. And maybe in India's laws or India's Data Protection Act, they also have different obligations that these companies, the cloud provider, has to follow. So at the end of it, whose laws are we following? Are we following the Ghanaian one? Are we following the Indian one? And how easy is it for me to tell them to like sort of change their ways to follow my country's laws? So that also becomes an issue. And how will you access your files? Will you access it through a VPN? Will you access it directly? And there have been cases where users have been logged out of accounts and then they lost access to it because assuming you lost certain vital information, let's say your private, like for some accounts, you don't need a password. You might need to have like a secret key to be able to log in. So within those periods, then you would have to sort of, assuming you've lost it, it will be very hard if you can't prove that you really own it and then all your data is gone. I once had a VPS, a virtual private server. We were trying to develop a USSD application, right? Where people would be doing savings. So every morning, it sort of gives you a notification that, hey, do a savings, but you do it through USSD, right? So for that, to be able to do that, we have to communicate with an API, which will do our payment for us through USSD. And then they asked us that we need to have a permanent IP address, like a static one that does not change. So we had to purchase a VPS from Bluehost, right? Virtual private server. And more like, for that one, they'll give you the whole like server, and then you can install anything you want on it. So once we are using this VPS, we got to a point, I think we used that tool for like, I think a year for testing, just a full year for testing. So after testing, whoever told us to do the software or the whole application was supposed to pay us to do the renewal, but then he delayed. And once he delayed, the subscription ended. And once it ended, can you believe that the cloud or Bluehost did not even keep our server, or did not like maintain our server for like 2 days and say that we are giving you a grace period of 15 days, come and pay so that you get your server back. Once the subscription ended on that day, I think the guy brought the money there 2 days later. We paid for it and we went in there, and every database we've set up, every files we placed on the server, everything is gone. Now we need to set up everything again, install every tool we need all over again to be able to host it. The only good thing was that we made backups and we downloaded them offline because we knew it was about to expire. But then in such a case, assuming we didn't have backups, that means we've lost all our data. And that is one of the challenges of cloud computing, right? So it supports redundancy. And then the redundancy is like where you sort of make backups of the data in several places so that you can always sort of renew it, like regardless of having the same data replicated in several places. But in Bluehost's case, maybe they had it, but they just decided not to do it for us. Maybe now they've changed their minds, or they have become, Momtas, perfect people, and they are doing the right thing, hopefully. So now disadvantages of cloud computing is that, first of all, it requires internet connection all the time, because cloud, excuse me, because cloud computing is impossible if you cannot connect to the internet. Obviously, I can't be in Ghana and be connecting to a cloud service provider in India or Delhi, and like there's no way I can get there without the internet. Like So it's very important that we should always have internet. So once your internet goes off, it means that you can't work, assuming you are dependent on this to work in a day, right? There was a day I was supposed to do labs and then my internet just shut down. I think it was like the whole Ghana. It shut down for like 10 minutes. And during that period that it shut down, it means I couldn't connect to Zoom. It means I couldn't send a message. It means I couldn't do anything. And assuming my work depends on it, which it did, because I literally do everything from home. Assuming my work depended on it, that means that day I've lost some vital deal. Assuming I was going to sell my company, Derick, my company that I have with Salmi and then with Rejdan, assuming I'm going to sell that company for like $4 million that day, I might have lost that money because there's internet failure, right? So that is one of the disadvantages of cloud computing. Now, it goes on saying that stored data might not be secure, exactly because you don't really know how they are storing your data. They can even lie about it. And then also the data can also be lost, which I've already explained. Now, we have cloud service providers, and these are organizations that provide cloud computing services, right? As simple as that. A cloud service provider is an organization that provides cloud computing services. So can anyone tell me one cloud service provider they know? What organization do you think is providing cloud computing services in this modern world?
Yes, Google and Facebook and Amazon and IBM and so on.
Okay, thank you, Weston. So AWS, again, I don't think I want to hear AWS in this class again, based on what you guys just did to me like 10 minutes ago, where you all chose AWS.
Yes, and the Derick Cloud.
And Derick Cloud.
Derick, yes.
I appreciate that. I appreciate that. I think I was sharing the profit 50-50 with Salmi. I think now we can sort of change it. I think I'll take 40 and then you and Salmi will take 30-30. I think that's fair. I appreciate that. So Digital Ocean, yes, there's Digital Ocean, there's Heroku, on and on and on. So these are all cloud service providers. Now, the cloud deployment model, like how are we deploying the cloud, right? It literally classifies how the cloud service is being owned or provisioned. Like, how are you providing it? Who are you providing it to? Who owns the cloud? Like, who owns that particular resource, right? It's not all the time that cloud computing would belong to an external organization. Some organizations can set up their cloud infrastructure in-house, in there, right? They can literally, like, I can be here in my house and set up my cloud infrastructure in here, so that even if I travel to Kuwait, I'm always able to, access the resources over here because I've set up my cloud infrastructure. Now we have three main types of cloud deployment models, and the first one is public, right? Public is a multi-tenant model, and it mostly has to do with subscriptions, pay as you go, and then it has tiered service and support with shared resources. So for public, all that we are saying is that the service is offered over the internet to several cloud consumers, right? So it's at that point, if I want to access any cloud, right, and I can be able to access it over the internet, regardless of me owning it, like it doesn't belong to one organization. As in, they are not providing that service to only one organization, right? But then they are providing it to a whole lot of people. Like Google Drive literally qualifies as a public cloud, or Google Cloud Services, right? GCS qualifies as a public cloud because anyone can just go in there and then do a subscription. AWS qualifies as a public cloud. So all these organizations have the ones that they do for the public and the ones that they do privately, which we'll get into shortly. And then the risk of this mainly has to do with performance and security, because an external agency is providing these services to you, you don't really, you can't really pinpoint how much security they have, which policies they are following, and all of that. And then also when it comes to performance, if 1 million people are accessing the cloud, you will now be concerned, would this thing still be fast enough? Would this thing still accommodate me, even though 1 million may be okay, but let's say 10 million, let's say 100 million, let's say 1 billion people are accessing it, would this thing still be enough? So some people will just be like, okay, because of performance, blah, 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 I don't want to do this anymore. Now, Then there's also private. Now with private, we can say that, okay, private can have a sub-entity, which we'll get into shortly. So private, basically, a private cloud is owned by an organization, right? And is mostly on-premise or off-site. It could either be in my house, or it could be, let's say, I could be here in Ghana, but then my cloud could be in maybe New York, right? But then as long as it is owned by me, as long as it is owned by Derick Cloud Services, right? Derick and Sons and Daughters Cloud Services, it means that it is a private cloud, irrespective of the location. It could be on my company premises, or it could be off-site, anywhere else. As long as it is owned by me and I'm the only one using it, we can call that a private cloud. Now, there's a type of private cloud called the hosted private cloud, right? And hosted private cloud is hosted by a third party, but then for the exclusive use of one organization. So in this case, Derick Cloud Services, I want to create my cloud, but maybe I don't have the expertise to create it. So therefore, I'll contract Salmi. Maybe Salmi has this IT company that can set up cloud. So then Salmi will set it up for me, host it for me, but then I'm the only one that has access to it. So that one is a hosted private cloud service. Is that making sense? For the hosted private, yes. So for the hosted private, in as much as it is mine, I'm not the one housing the service. I've given it to someone else to house it for me, and I have access to it all the time, right? So then we have community. Now, sorry, we have like the regular private. For that one, I'm the only one that owns it and is always on site. And then we have community. Now for community, several organizations will share the costs of either the hosted private or fully private cloud. All we are saying is it is being used by several organizations, and all participants would share the cost and the resources. Okay, it could either be a hosted private type of cloud, or it could be a fully private type or a fully private cloud. That's for the community. But then it's only specific organizations that have access to it. So Derick Cloud Service, so like universities, combination between private and public cloud. Yes, exactly. So for universities, they can just mix it up. And then that one will qualify as hybrid. So if there's a cloud service that several universities are accessing, right? And it's only for those universities, 5 universities come together, King Abdulaziz University. I think there's one university I heard of. Was it Princess Nora? I might be wrong, but there was a university like that. Am I right that there's a university named Princess Nora University?
Yes,
yes. I heard that. I heard that in the interview. Thank you very much. So then, let's say King Abdulaziz University, Princess Nora University will decide that, okay, we need to have a cloud service, but then we can't host it ourselves. So let's get a company to host it for us, right? And then we are the only ones that have access to it, no other person, just these 2 universities. So that will qualify as a community cloud. And then maybe we could also decide that, okay, they will be the ones to host it. So Princess Nora owns the cloud, and then maybe every other Abdulaziz University has it. And then I think Saudi Electrical University, I think I heard that one too. So all of these qualify as community, right? And then the hybrid is where there is a mixture of the public, the private. Most of the time, it's mostly a mixture of the public and the private, right? That is the community. Now, so this was how we deploy the cloud, right? How you are providing the cloud service, or how it is being owned. That is the public, private, and then the community. Now, the next one is cloud service models. Now, cloud service models are basically reference models, okay? And for reference models, we are saying that, what are you providing to us? If you are providing cloud services, what exactly are you giving to us? Are you giving us just the hardware so that I'll go and install my operating system on it and do what I want? Or you are giving us the hardware and the OS so that I will just install the tool I want? Let's say I want to run Kali. So no, let's say I want to run John the Ripper, right? So that I can just run John the Ripper. Or you are providing everything and just giving me access to the software. So these are the three different kinds of cloud service models. And the first one will be software as a service. And for software as a service, so for software as a service, it's basically where software is being distributed, but then it is being hosted by a vendor or service provider over the network. So for example, we have things like Microsoft Office, right? You know, there's Office 365, which you can literally access it. You don't really need to host it. Microsoft is hosting it for you. So for that one, it's a cloud service, but then you don't host anything. Microsoft is doing all the hard work. You are just accessing the software part of it, which is the Office 365, using Microsoft Word Online, on and on. Even your Gmail application, do you know what infrastructure is behind it? No. Do you know what operating system is running on Google servers for you to have access to Gmail? No. All that you are accessing is the Gmail part of it. That's all you care about. And that is software as a service. Now with software as a service, most of the time you might have to pay for it, right? And then it is not easily customizable. That is the unfortunate part, because someone has provided their software to you as a service and you are just accessing it, right? And the only benefit with software as a service is that you get automatic updates, right? If Google updates their Gmail on the cloud, I don't mean the app you have, right? If Google updates the Gmail that you access by going to gmail.com, would they tell you that they have updated it? All you see is that they've done an update, and then you see that the interface is changing. So there's mostly auto updates. And then with that one, all users have the same version, just like Office 365. And then also it ensures easier collaboration because we are all using the same software. We don't own the software. We don't even own the infrastructure. All we are using is the software part of it, and that is software as a service. So most of the time, they won't give you a license so that you own it forever, but then it's mostly on a pay-as-you-go plan, right? And with that one, it could even have inbuilt billing, like Office 365 like this. You would have to, be paying every month, maybe yearly, and on, right? So examples could be like a marketplace where you have to buy stuff. It could be like built-in billing. Okay, so these are the things that it has. It could actually have premium CDN and DNS. So premium CDN is a content delivery network, which sort of basically it's able to help with load balancing. It's able to cache websites, make you access them so quickly and all of that. It does a lot like security and all of that. And DNS actually helps with processing requests. So premium CDN and DNS means that because you don't own the software, Google will be providing all of these things to you, right? These are some of the features. Now, the next thing is the platform as a service. Now with platform as a service, right? I think we've seen them here. Let's skip to the next slide because I like that image better, right? Can you see my screen, people? Like, can you see it? I'm trying to get a pen. All right. So now software as a service, platform as a service, infrastructure as a service. Now, let's take them like this, right? Ignore what's at the top, it's just the list, but then take them like this, okay? Like this. Ooh, perfect drawing. I'm following Mr. John's lead with his perfect drawings. Then that's the third one. So we have one, we have, three, beautiful, good, Momtaz, perfect. So now we have all these three, right? And then so we just talked about software as a service. And as you can see, for software as a service, all these things are provided. But then let me skip down to infrastructure as a service, all right? So for infrastructure as a service, you will notice that this is a cloud, and then this is infrastructure as a service here, right? And for that, it provides IT resources like servers, load balancers, storage area networks, all of this so easily to you, right? And as you remember, it's on demand, so pay as you go, right? The good thing about infrastructure as a service is that it is scalable. Scalable means that if you are using, let's say, 10 gigabytes, and then your system starts exceeding 10 gigabytes, you can just upgrade your plan to like 20 gigabytes. It's as easy as that. You don't need to go to town and go and buy another storage, right? Electric. I'm not getting that though. But can you explain what you mean, Ahmed? But you remember when for those of you who were here yesterday, before Mr. Somi did his lab, Abdullahi mentioned that they went to a marketplace and then they had to, they got lost. Does anyone know the name of the market? Can you remind me of the name of the market where they got lost yesterday? Was anyone here when Mr. Abdullahi was talking about going to the market and then he couldn't find his car?
Yes.
Yes. Can you tell me the market? Al-Batta. That's the market.
Al-Batha. Yes.
Al-Batta. Good. So that's Al-Batta. And then, so this is what happens, right? Assuming you have 10 gig and then you realize, okay, the 10 gig storage is no good. You need to get another 10 gig. You don't need to go to Al-Batta to get like extra 10 gig to come and put on the server because you don't own the server. All you need to do is to go online, pick a new plan, and then at that instant it is updated. You don't need to do anything. So that's where infrastructure as a service comes in. An example includes like Amazon Elastic EC2, Microsoft Azure virtual machines, Oracle Cloud, all of that. But for this one, you would have to put your own applications on it. You would have to put your own platform on it. So now you might have to install your own operating system. Now, probably if you want to run Kali, you have to now install maybe Kali, install all the dependencies, and then even install John the Ripper. The benefit is that it is cost effective, it is scalable. But then one of the issues is that whenever you decide to sort of stop these services, they might not fully erase what you had. So you need to know the data erasing policies of such organizations, because sometimes you might end your subscription with them and they will not delete your details. They might just do a soft delete. And then another person comes in, they will do 1 or 2 commands, and then they will find some of the files that you were using in the past. So that is one of the issues that we have with infrastructure as a service. And then also legacy software vulnerabilities, like assuming, because there's an infrastructure, so they have maybe some basic things sitting in there, and then if they are not updating these things, it can be very annoying, right? So from infrastructure as a service, we now go to platform as a service. Now for platform as a service, it provides resources mostly between software as a service and then infrastructure. As you can see, is literally in the middle, right? And sometimes most of the things that will be providing will be the server and then the storage network infrastructure, right? And then sometimes it could be providing a database only. Sometimes, yeah, mostly we'll be providing a database. It could be Oracle database, it could be Microsoft SQL database, because you already have the server here, you already have the network here, but now you need to put certain things on there. So maybe you have now installed Oracle database or MySQL database so that you will be able to communicate from here to this side. Then for so the issue with infrastructure as a service is that the service provider would have to take care of the integrity and availability of the platform. But then you, the person, will have to deal with the security, like whatever you are installing, the Oracle database, how secure is it? You know, that kind of stuff. You have to deal with that kind of security. Then for software as a service, we explained it whilst we were on this particular lab. And then we mentioned that it's, you will get automatic updates and all of that. But then one thing that is also the issue about software as a service is that it can be vulnerable to browser-based risk, because literally you don't own anything. All you are doing is accessing it through a browser or accessing it through whatever application it is. And in the end, whatever risk or vulnerabilities that your web browser could be prone to, you would be vulnerable to them too. For example, a cross-site scripting attack, cross-site request forgery attack, you know, so many things, because it is in your browser. Assuming you've opened your bank application in one tab, and then now you are trying to communicate with one of Xiaomi's dangerous links. And then maybe Xiaomi's dangerous link is able to pick out your cookies. Because you've opened it in the same browser, it might be able to pick out that information, and then I mean, Sami is not like that. That's a disclaimer. He's not like that. He doesn't even know what hacking is. If any law enforcement person is watching this recording, I put on record that Sami doesn't know anything about hacking. Okay, so now moving on, right? You will notice that we have software as a service, which provides applications. We have we have platform as a service, which for that point, you would just be, so for example, if you have developers who wants to develop on, let's say they want to develop a Python application on the cloud, a service like Heroku would provide that. So they will ask you, what do you want to develop? You're like, well, I want to develop a Python application. They will ask you to choose what you want. Maybe whatever they give you would already have Python installed. They might even have a database installed already for you. So that becomes platform as a service. And all you have to do as developers is just go in there and then code away. But then for infrastructure as a service, you might have to install the OS on your own. You might have to do a lot of things on your own. So that's the 3 cloud service models. Now, there is also security as a service, because regardless, we are here to talk about security. So when it comes to security as a service, we are dealing with, we can actually have consultants. I think Sami has operated in this capacity for a while, right? And consultants would help with SIEM, SIEM rollouts, and then even pen testing, right? You don't want to do these things on your own. You want to sort of get someone else to provide that as a service. It doesn't always have to be these 3, right? It doesn't always have to be a software. It doesn't always have to be software. It doesn't always have to be a platform or infrastructure. There's even a part called anything as a service. Meaning I can even decide to say that my cloud is singing as a service. Like that is what I provide. I sing for people as a service. That's the thing. You can do as anything that you want and it will qualify as a service. But that's just by the way. So you could have consultants who would bring in their experience, right? Because they are literally third parties. They don't belong to the organizations. And then because they have that experience, they could help with providing product-focused projects and probably helping with pen testing, making sure your infrastructure is good enough. Now, there's also MSSPs, which are managed security service providers. Now, MSSPs, for this one, you are fully outsourcing your security responsibility to a third party. They are managed security service providers. So it's mostly for small and medium enterprises. And assuming, let's say, Derick Cloud Services has started, we had just 10 customers. So we were able to just use our in-house servers. Now we've got to a point where we have like 100,000 customers and we feel like our security is not enough. So we might now purchase, or you might now subscribe to an MSSP who would be handling our security for us. They would make sure all our devices are updated. They will make sure that every single security policy is being adhered to. Like, it's literally like you've gone to hire a whole security department and then they are working on your organization. Like, you don't have to think about it. And people actually go for this because it's quite straightforward and a bit easy. But then for this, you really have to trust whoever the MSSP is, the managed service security. The managed security service provider is, you really need to trust them, because recently there was an attack. I've forgotten the organization, but then there was an attack and it was through the MSSP. I don't think it's Mandiant. It was one of that one. I've forgotten them. So there was this attack where the managed security service provider was hacked because a VPN, a remote VPN account or a dormant VPN account was used for the attack. Now, when people hack this MSSP, because this MSSP is managing so many organizations' security infrastructure, that means whoever has had access to the MSSP literally has access to all their customers. So you see the interesting part of these things. It's very, very interesting. So you really need to trust whoever it is to give them that access, because they literally have access to all your infrastructure. Then the last one is security as a service. Now, for security as a service, it mainly has to do with implementing a particular security control, and such as sometimes virus scanning, or sometimes basically like that's it. So for Cloudflare like this, Cloudflare, I think I explained earlier, Cloudflare provides that kind of protection. If you have a website, Cloudflare can protect you against denial of service attacks because they have this whole infrastructure thing. So any traffic that comes to your website would go to Cloudflare before Cloudflare will forward it to you, because Cloudflare actually has this DNS thing going on. So in order to set up Cloudflare, I think I've said it a few times on several websites, you have to, Cloudflare will give you their DNS address, and then you go to wherever you are hosting your website and then replace it with that. So once you replace it, now all of your traffic, anytime someone puts in Derick.com, it would go to Cloudflare.com. They will process that traffic, make sure it's not an attack, and then they will forward that traffic back to you. So that is what such security as a service organizations do. You could literally be here, and then you have an antivirus software on the cloud that is actually scanning your files and everything, meaning you don't have to put everything on your systems, and it could literally be from the cloud. Now, virtualization technologies and hypervisor types. So I'm going to try and make this as simple as possible because it could get messy, but I'll try and make it very perfect. So we have, when it comes to virtualization, right? Virtualization means that you have multiple operating systems that can be installed on a single computer. That's literally virtualization. You have VirtualBox on your system. It is providing virtualization. So many VMs are isolated from each other. Thank you, Westan. So we have the host hardware, we have the hypervisor or the virtual machine monitor, and then we have the guest operating system. Now I'm going to explain these three shortly, and then you are going to tell me which of the things you've used so far in this bootcamp qualifies as each of them. Okay, so now host hardware is the platform that will host the virtual environment, right? So there may be multiple hosts networked together. So for example, the host hardware is literally, I literally said that I was going to make you guys say it, but I might have to say it. So host hardware is the physical infrastructure that you have. So probably right now, your host hardware is your laptop. Your host hardware is your laptop in simple terms, right? Now the hypervisor or the virtual machine monitor, it is the software, right, that actually manages the virtual machine environments and facilitates interaction with the computer hardware network. In simple terms, your hypervisor in this case is the VirtualBox application you have on your system. It is the software that would facilitate that communication between your host operating system and whatever virtual machine you are going to install. Then you have guest operating system. These are basically the virtual machines or instances of operating systems you have installed in your virtual environment. Now, what is a guest operating system you have installed in this bootcamp so far?
Which is Kali Linux.
Kali Linux, that is your guest operating system. Any operating system that was not originally, or like that is not currently your host operating system, is your guest operating system. Any operating system that exists in your VirtualBox application, or if it could be VMware, it could be any other one, that is your guest operating system. So the hypervisor is the VirtualBox application you have, because it literally provides that connectivity. It is able to provide that connectivity, that environment that will make it possible for another operating system to run without interfering with your host operating system. So as you can see in this diagram, we have type 1 hypervisor, and then we have type 2 hypervisor. Now, if you look at these example, right, the main difference between the two diagrams is the operating system. Meaning that if you are using type 1 hypervisor, sorry, if you are using a type 1 hypervisor, it means that whatever hypervisor you have, or your virtual machine monitor that you have, is directly installed on your hardware. And your hardware is your laptop. So then it is directly communicating with your hardware, your processor, your RAM, your storage, everything directly. So you have this hypervisor software running directly on your hardware, and then everything else comes after it. But then for a type 2 hypervisor, you have a host operating system, right? Oh, okay, beautiful. So this is your host operating system, right? And then you have the hypervisor on top of it before you can now host several OSs on top. Now, in this case, this is Kali. Okay. Oh, this is not going well. Wow. Then this is our VirtualBox VB. And then this is our laptop, specs, right? So like ESXi, exactly. So ESXi qualifies as a type 1 hypervisor because it is directly installed on the hardware, which is like, so for this, it will not boot into your Windows operating system before you have to come and run virtual machine. Before you have to come and run VirtualBox before you can start your Kali. No. For type 1 hypervisor, the hypervisor or the application that is providing that virtualization capabilities is directly installed on your system. So once your system boots, it will boot into the hypervisor. For example, the the VMware, the ESXi that Fahad sent is from VMware. Microsoft also has one named Microsoft Hyper-V, and then Citrix has one called the Zen server. So once you boot your computer, it would boot into that VMware ESX server here. And then now you can start whatever OS you want to start. It could be Kali, it could be, Ubuntu, it could be Mac OS. Anything you want, it would be able to run it because you don't have to have a host operating system. But then for type 2 hypervisor, there has to be a host operating system running so that you install your VirtualBox on it before you have your OS, and then whatever application you want to run, you will be able to run it. All right, is that clear, please?
Yes, it's clear.
Okay. Are you guys sleeping in the chat? Because it looks like my chat people are like dormant. Because they are like my main population, and then the speakers are my ministers. Okay, thank you very much. All right, now we have VDI, which is a virtual desktop infrastructure. Now, let's forget all of this, right? All of these descriptions, and let's look at this diagram. What do you see here? Like when you look at this diagram, what do you see? We have 8 minutes. Can you be quick, please? If you look at this diagram, what do you see? Like something, yes, laptops, a server, good, perfect. That's the only thing I need. So you have laptops connected to a server, and then, so no one mentioned cloud. Can't you see the beautiful cloud? Some even mentioned is a pillow cloud. So we have the cloud too. So meaning that these computers are connected to the cloud, right? And as you can see, each computer, right? This is a monitor, there's a monitor, there's a computer. The reason why there's a monitor is because they are trying to tell you that this server here is a virtual desktop infrastructure, meaning that it is able to provide a virtual machine to each person that connects to it. So one virtual desktop infrastructure server could have about 10 Kali Linuxes running on it. So this particular computer, which belongs to Rejan, would access this one, the first VM. Now, Rahat would access the second VM, right? Then Atia, I'm checking through the chat for the last people who commented. We'll have that. And then Mishairi will also have access to this particular. So then that is Mishairi, right? So in a way, as you can see, VDI allows you to have access to a whole operating system, but then your host system, like the system you are using to connect to it, do not even need to have any power at all. You can literally be running like 1 gig RAM over here, and then you'll be able to run it, meaning that this particular infrastructure or server is doing all the hard work for you. It is running the process. You know, when you run Kali on your system, some of your systems become slow and everything, right? Because it is trying to use your RAM and your processor and everything. But in this particular infrastructure, this guy here, the server, is actually the one giving you the processing power, giving you the storage. All that is doing is that it is giving you remote access. So all that Rejan has to do is to have a mouse and a keyboard and a screen. We don't need even that thing to even have that much power, right? So as we're saying, running VMs on limited processing power. So in this way, organizations are able to just give out, like, tell their people, well, We are not going to give you a company laptop. Whatever device you have, whether it is strong or not, just connect to this website. Just go to your URL, connect to this website, and you have access to your VM to use. Now, there is a persistent virtual desktop infrastructure, and then there is a non-persistent virtual desktop infrastructure. These are the two types. Persistent means that it will save whatever you do on it for future, for future reference. So I can work on my phone. So with this, you can work on your phone. You can even work on your, assuming this has touch functionality. So I can work on my phone today and then just go and sleep. The next day I can come back in, log in again, and then I can access it again, right? That is the persistent virtual desktop. That is mostly used for work. And as you can see, it's a 1:1 thing, meaning that one person has access to one virtual machine, because we want to save your work for tomorrow. If we allow 5 people to use the same desktop, how will we be able to know that this virtual machine belongs to this person? So 1:1, which is the persistent virtual desktop, belongs to one person. Now, the non-persistent ones, those ones, whenever you turn it off or you shut it down, it would reset itself to its original state. So assuming you are running Kali, you are running John the Ripper, you are doing all of these things. Once you shut it down, all the tools you have installed will vanish and it will go back to its original state. So tomorrow when you come in, everything is just like starting afresh. So that is where the non-persistent virtual desktop comes in. And for that one, it is used mostly in public libraries, computer labs. And for that one, it is a many-to-one infrastructure, meaning many people can access the same VM. But then for persistent, 1:1. All right. So we are literally 3 minutes away. So I'm going to go to the next slide, which is we have about 8 slides to go, but we'll continue that tomorrow in addition to tomorrow's slide. And this particular one needs more explanation, the difference between containers and VMs, but I'm going to make it as quick as possible. So you would notice that for a regular VM, right, which we just saw, say the host is here, the server is here, which is the infrastructure, like the hardware. Now we have the type 2 hypervisor, and which is like, what is an example of the type 2 hypervisor? Can someone tell me in the chat? What software reminds you of the type 2 hypervisor? Anyone? Are you guys aware that like we are doing this online, so it's very silent if no one talks? Like it's very, very silent, it's like a cemetery. Does anyone know what, like, can anyone give me what example? Because we gave samples here. That types exactly the virtual box we are running. Thank you, Gaida. So the virtual box we are running qualifies as a type 2 hypervisor. And then we have Kali here, right? That's the guest OS. Then at that point, maybe each guest OS has a set of libraries that needs to be installed. You remember when you had to install Snot? You see what you had to go through just to install something? Just because you wanted to run one application like Snot, you had to go through installing so many libraries before you could have access to the application. But then for containers, the infrastructure is here. Now the host OS, which is our Windows, is here. And then we would install the container. And in this case, we'll be using Docker. So Docker is one of the top of the shelf, like Docker is like top of the shelf infrastructure. And then containers are isolated by the shared operating system with resources when it is necessary. So you would see that the Docker engine is actually not installing any OS, but then it is making sure that if you want to run Snot, right? This is Snot. If you want to run Snot, it would allow you to have access to all the resources that you need to run Snot directly. And it would give you, as you can, the yellow one is the same as the bins and the libraries, right? So it would give you any library you need. A library is like any dependency or any extra file or application that you need. So let's say you want to run Snot, you might need to install another application before Snot can run. So Docker sort of just gives you access to only the libraries that Snot needs. It will not install a whole virtual box, install all the tools in Kali, John the Ripper, everything before you can have access to Snot. No. Once you need access to Snot, Docker will allow you to run just Snot in a virtualized instance. That's it. So virtual machines are very large. It could go into gigabytes, but then with containers, they are very small, very light, sometimes few megabytes, because you are just trying to run one application. Now, applications on virtual machines could have different OSs. You can see there's multiple OSs here, but then for a container, which Docker is an example, right? A container, for containers, they all don't have individual OSs. Every application here will share the same host OS. Just one. They are all sharing just the one OS, right? So that's the difference between the two. There won't be so many guest OS before you can run applications, and you can always run whatever you want. So that brings us to the end of today's slides. Tomorrow we have the last 8. I think we've done 14 so far. So we'll continue with the last 8 slides, and then we'll be done for this, and then we'll move on to the next one. So I'm going to end the recording here.